Let us do combination sums when at least is present in the question. Sandra wishes to buy some applications for her smartphone. She only has enough money for five apps in total. There are 3 train apps. You came across information, write it down. There are 3 train, 6 social network apps, so 6S, and 14 games apps available. Sandra wants to have at least one of each type of app. At least one of each type means at least one mean one or more than that. And mathematically, how do I represent that? In this way. Greater than or equal to 1 means one or more of this app. On each it is, so the condition is for each of it. Clear? Now from all this, she wishes to select any 5. So she needs to select 5. Continue. Find the number of different possible selections of 5 apps that Sandra can choose. From the given, she has to select 5 apps. Clear? Now, you come across multiple options, so make a table. One column for T, S and this, and you need to select in total 5. Clear? Now, whatever number you write here should satisfy this condition. Whatever number you write here should satisfy this condition. Whatever you write here should satisfy this. And also, the count of these 3 numbers should be 5. When you add the numbers present here, should add up to 5. Let us see how many such numbers do we get. Here it is greater than or equal to 1, so let us say I start with 1. Here also if I take 1. Here 1 plus 1, 2, so this has to be 3. Only then the total count will be 5. Okay. Next, same. 1, this time I increase this to 2. So 1 plus 2, 3. So here the number should be 2. Only then the count will be 5. The count is 5, each number is satisfying the condition. Okay, next. I place 1 and I increase this again to 3. 1 plus 3, 4. So here it has to be 1. Only then count will be 5. Clear? Next. If I take here 1 and I increase this to 4. 1 plus 4, 5. That means here it has to be 0. 0 is not satisfying this condition. What I conclude from that is, with 1 only these options I will get. Okay. Now next, I will increase this 1 now to 2 and I place here 1 since starting is 1. 2 plus 1, 3, so here it has to be 2. Then only the count will be 5 and each number is satisfying the condition. Okay. Next, 2 here, increase this 1 to 2. 2 plus 2, 4 and 1, 5. If I take 2 here and increase this to 3, 2 plus 3, 5 and here it has to be 0. This is not satisfying this condition. From that my conclusion is with 2 only these options. Okay. Now, I will increase this number to 3. Here 1 and here also it has to be 1, then only the count will be 5. Next, if 3 here and I increase this to 2, 3 plus 2, 5, that means here it has to be 0. This does not satisfy the condition. From that, conclusion is with 3 only these one row I get. Even if I take 4 here, if I take 1 here, here it has to be 0. Only then the count will be 5. If it is 0, it's not satisfying the condition. So I conclude that I have only these options satisfying her condition and the count of 5 apps. Clear? Okay. Did you understand? If you go in a particular organized way, you will not miss any option. If you randomly choose numbers, there is always a doubt of missing out some options. Okay. Now let us write for each. For this, from the 3 different apps, she needs to select one that can be done in 3C1 ways. From 6, she needs to select one that can be done in 6C1. From 14, she needs to select 3 that can be done in 14C3. It is and between them, so you will put into sign. Did you understand? Same way I write for other rows. For this, it will be 3C1 into 6C2 into 14C2. And for this row, 3C1 into 6C3 into 14C1. For this row, it is 3C2 into 6C1 into 14C2. For this row, it will be 3C2 into 6C2 into 14C1. For this row, it will be 3C3 into 6C1 into 14C1. Okay. Now, it is or between them. Whenever it is or, you need to add. So, add all this to get the final answer. So, whenever you add, your final answer should be 13839 is the answer that you should get. Okay.